Okay, so we're looking at complex numbers in polar form and what's the benefit of them. Well, one of the benefits is that you can actually, one of the benefits is, so it's a very easy way of multiplying complex numbers. So we have our first complex number here, Z1 equal to the modulus of it. We have our modulus R1 and the argument θ1. Over here in red we have Z2 and its modulus is R2 and its angle, its argument is θ2. Right, so to multiply complex numbers in this format, Z1 times Z2, all you need to do is you need to multiply the two r's and add the two angles. So you multiply the two r's and you add the two angles. And then to divide complex numbers in this form, you just simply divide the two moduli and subtract the two angles. Now it's always a nice idea to put the bigger angle first if you can at all, because that avoids the whole problem of having negative angles. Okay, so here's a simple example. So we have Z1 here, I have it already written in polar form, root 2 times the cos of pi over 4 plus I sine pi over 4, and Z2 is 4 times cos of 3 pi over 2 plus I sine 3 pi over 2. So like we see here, we just have to multiply the two r's and then we add the two angles, and then on our calculator we add these and we get this here, and then we get 1 over root 2 when we get the cos of this on our calculator. Well, actually that wouldn't be the calculator, that would be from your tables book. The calculator will give you root 2 over 2, and that will still work out then by multiplying them and going back into rectangular form. You'll get Z1 times Z2 equal to 4 minus 4i. Exact same thing for division, but for division we take the moduli and we divide them. Now you'll see that this has a 1 here because there's no the length of this complex number is 1, so there's a 1 in there, but we just don't bother write it down. And this time, remember, we're subtracting our angles. Okay, now the blue one is first because pi over 2 is obviously bigger than pi over 6. Now you'll get the same answer the other way, but you'll just be dealing with negative angles and it just might make life a little bit more difficult. So again, you subtract those in your calculator, you get pi over 3, and then you can look up these in your tables book or use your calculator, and then you'll get that your Z1 divided by Z2 is 1 over root 3. Okay, so the last thing then is, and this is called the Moivre's theorem. So the Moivre theorem allows you to put a complex number to any power. So if we look here, there's our complex number Z, and here we are putting it to the power of 4. Now how would we calculate that? Well, this is obviously very long-winded, writing out the same complex number 4 times. But what we've just learnt in multiplying complex numbers, we know that all we need to do is multiply the 4 moduli here in front, and we need to add the angles. And obviously the 4 moduli are the same and the 4 angles are the same because we're dealing with the same complex number to the power of 4. So another way of writing repeated multiplication is exponentials. So we get r to the power of 4. And then here we have the cos of 4θ because repeated addition is multiplication. So basically, if we look, what does it tell you to do when you're dealing with polar form? So if I have z to the power of 5 of a complex number, of that complex number here, I put r to the power of 5, the cos of 5θ, so multiplying the argument by 5, plus I sine of 5θ, and then close it up. So you put the modulus to the power of 5 and you put 5 times the angle, and it's as simple as that to raise a complex number to a power. And now our example then. Okay, so I have z equals root 3 plus I, so the first thing I've done here is actually converted it into polar form using the r and the θ. And then once I have it in polar form, then I put that number here to the power of 3. So that means I put a square bracket around all of this into the power of 3. Now the Moivre's theorem tells me, okay, that I put the power of 3 on the 2 and I multiply the power of 3 in by the two angles, leaving with 2 cubed by the cos of 3 pi over 6, which obviously goes down to cos of pi over 2 plus I sine pi over 2, and then using your calculator to work out those in rectangular form and not forgetting to multiply by your 8.